Alright, so let's start with the first session in math. A few things regarding this section before we really proceed. As things are written here, I'll just discuss them at length with you. So the first thing, raise your hand if you're applying to American schools next year. Okay, just raise your hand. If you're not applying to American schools, please raise your hands. I think I didn't see anyone then. Applying to Asian schools only? European? No, only Asian, only European schools? No one really. So if you're applying to American schools, okay, only Asian schools for you. Alright. If you're applying to American schools particularly, then more than your overall GMAT score, your quant score will count separately for a lot of schools. Okay, quite a lot. This is something that you should know. If you're applying to Asian schools or European schools, your overall score counts. Usually your other score, quant individual score does not count if you're applying to other schools, but American schools particularly that are looking for people in consulting or people in banking, investment banking, international operations, whatever, these essentially analytics oriented roles, quite a lot quant heavy these days, and you really need to have a good quant score. By good quant scores, all of them believe it's only 50 or 51 in math. 49, although the highest score is 51, but 49 is considered a low score because what reason do you think? What is the percentile? If you have seen the GMAT percentile ranking tables, what is quant 49? 83, 84 percentile. So you can see anything around 90s if you don't have, it is very difficult. So you got to have a score of 50 or 51. Now this particular thing makes the quant section more difficult. In the verbal section it works a little differently. If you say verbal overall score you have is 45, out of that even if you get a 39, 40, 41 it's considered really good because strangely in verbal a score of 40 is 90 percentile, 90. In quant a score of 50 is 89 or 90 percentile. So the two scales are not comparable. So one of the important things here is that you have to get only a 50 or a 51 score. What you understand by this is if you get a quant 51, essentially you get nothing wrong actually. So you get everything correct, then only you'll get the highest score. This is the highest you can get. Quant 50 will mean you get a maximum of 3 wrong answers. So the point is not that quant is difficult or easy, but to reach this level of accuracy, you have to make sure you can't make a mistake of a silly kind. You say, I know all about math. I can very clearly say that whatever is given today in your handout already in these DS 25 questions, at least for 22 of them, you know the theory at least. You know that, okay, what is even number, what is odd number. You know the concept behind it for sure. And if it had been asked as a pure math problem, most often you would be able to solve it also and get the answer. But in data sufficiency, you may know everything and you still may commit mistakes. So in math, the learning that you have to understand, first thing is traps for sure. It's a question of your language skills as well. When I say language skills, it doesn't mean linguistics or grammar or something. It simply means a lot of questions are open to two interpretations. And if you interpret it wrongly, you solve, you still have the answer choice available. So these people really know how you will make a mistake, how you will misinterpret, how you will pick the wrong answer, etc. So it's not that you will be forced to rework the problem. In normal math question, what happens? If you make a mistake, your answer doesn't match, you know you made a mistake. You can go back and fix it. In this particular exam, in a problem solving question, you made a mistake, normally you will have the answer matching with your mistake as well. So it's the big hassle here. That's one thing. Another, don't have much time, so your decision making has to be quick. Now whenever we talked about math, I think it always meant calculations, process, and it simply meant whatever is written as step-by-step process and formula. Can I assume this is true, that this is what it meant initially whenever math was in question? On the GMAT, no question will involve calculations of any kind. When I say calculations, really big calculations that No question involves calculations. None of them. There is nothing called a structured process beforehand that okay, I have an overlapping sets problem, tell me this is the way you solve it. I have a speed and distance problem, this is the way it's solved. You have to really be able to think on the feet, on your feet. And did you need any formula for any question in these 25? Did you feel that okay, I don't remember the formula, that's why I can't solve? Did it happen to you? Any question that stumped you because you did not know a formula? You may not have been able to solve it for a different reason, but formula at least is not a reason. So the calculations really do not matter. The processes that we have step by step, that okay, to solve this question, step 1, step 2, step 3, then my answer comes. That school approach just doesn't work here. And formula approach. So what works in that case is, first thing is, can you understand in 20 seconds what I'm supposed to do? And the remaining 100 seconds actually do what you have to do. If you say to figure out what to do, I take a lot of time, that has to reduce, because quick decision making, depending on how quickly can I really know what I'm supposed to do, that's one. And the other thing is simple, can you identify some traps? Can you read and get the right interpretation? And so on. Normally questions are not very difficult in this section, but they are tricky. It will be like most of the questions you will never know beforehand whether you got them right or wrong, and that's what takes more fixing than learning math. Also, sometimes it so happens you end up giving more time to a particular question, especially in the beginning. You'll just spend more time on a particular problem. Maybe someone has told you that initial questions matter more than the latter questions, which is not true, by the way. It's nothing like initial questions matter. And sometimes you come to know that you've spent a lot of time that you can fix by switching. Sometimes psychologically you have no clue how much time you spent on a question. Does it ever happen? And I have seen people spending up to 8 minutes and never realizing it until the clock showed. So when you take a mock test, it will give you a question by question breakup of how much time you took on each question. And when I see 3 questions, 8 minutes each, I am shocked and they are shocked more than I am shocked, because they believe, how can they take 8 minutes on a particular question? They would not believe it, but this happens. What happens in the overall scheme of things when you take 8 minutes on 3 questions? Otherwise your pace is okay. Look at this. You can't finish the section. So towards the end I have about 7-8 questions and I have a minute or 2 minutes to solve those questions. I'll scramble, make mistakes, and one thing that the GMAT hates, I told you last time also, is consecutive errors. You cannot make consecutive mistakes. 3 or 4 consecutive mistakes will pull your score down by 50 to 80 points. Just 3 or 4 consecutive mistakes. If you want to make 3 mistakes, or if 3 mistakes are inevitable, they cannot be consecutive. They have to be maybe one in the first 10, one in the next 10. So that is why it is advised, if a question is unsolvable at that moment, it's better to think about it for about 2 minutes and then move on by marking something. You can't skip, but you have to mark something and move on. It's quite crucial. Now this is a firm belief I have, and all the students who get good scores essentially have this belief. If your approach is correct, all questions on GMAT math can be solved in less than 2 minutes each. I haven't seen a single question in so many years that somebody got here and said that okay, it will take 2 minutes or more than 2 minutes to solve. If your process is wrong, you may take 20 minutes also. Maybe there are some questions on which you took a lot of time. When we discuss them here, you will know with the right approach they can be done. So most of the times you should really be thinking about the right approach. All the questions are essentially checking your logic and not your math skills. No math skills in a way are tested here. So more than math, your logic is being tested, as I just said. So let's see, on the basis of this, we will try to understand the section. Also, these are topics. You need not write anything. I'm sure we will discuss all of them in subsequent sessions. So you have algebra, statistics, basic arithmetic, geometry, combinatorics. Just tell me which topics are quite difficult already for you. That this is where I am sure I will struggle. Permutations and combinations, probability, same, and any other topic. Inequalities, you may have seen them. Yeah, all right. Tricky, I think, more than anything else. So you have statistics, you have arithmetic. Lots of arithmetic questions are asked. Work and time, speed, distance. You would have seen some questions in overlapping sets. So many students study French, English, Spanish, all that. All these types of questions. Compound interest is the first question we start with, so that is arithmetic. Geometry, combinatorics. So I haven't kept combinatorics for today because that needs some explanation. So in subsequent classes we will do one topic, not just one topic, maybe we will just do inequalities in one session and so on. So this is your entire range of syllabus. Do not have any favorites that okay, combinatorics I am weak at, so maybe one or two questions will come, I can leave. This is not a test in which the examiner decides beforehand that these are the number of questions you will get on each topic. You know that very well, that this is a randomized adaptive test, and you can have a situation of 8 questions on probability. You can have a situation of 0 questions on probability also. Same, in 2 of my attempts I have seen about 10 questions in geometry once and 2 questions in geometry the other time. It's very strange, you can't really predict because this is not picked up by a human being beforehand that okay, I have a syllabus, from each of the units I have to pick up 5 questions and so on. Nothing like that, it just doesn't work that way. Okay, if you are doing well, that is if you are around 50-51 marks, you will get more and more DS and less PS questions. This is also another thing. That means time wise this question doesn't pose so much challenge. Timing wise you should be able to manage. Accuracy wise definitely lots of challenge. So these are the topics that you have. I really do not think you should always have some favorites here. Any topic can come in any measure at all. So no such thing. So let's see. I'll have the first session completely on the data sufficiency approaches that we had. So let's see. That was good. How did you find this? Let's see. And I'll have a very slow discussion of each of the questions so that absolutely clear to you. Okay, so looking at the very first question, we'll also discuss how to approach data sufficiency right from the beginning. But looking at the very first question, first thing, how much time did it take you to solve this problem? Think about this very recent time, you know. Minute, less than a minute, 2 minutes, more than 2 minutes. What's your guess? More than 2 minutes. What exactly were you doing for more than 2 minutes? Was it reading the question and understanding, or were you trying to solve something else? Second part, you were trying to solve something. Did it involve some calculations at your end? Did you? How long would it look like, your calculation sheet? Half a page, full page, less than that? Just asking. Anyone who ended up doing at least half a page of calculations? Half a page. Okay, so what did we just learn before this? Calculations, formulas and step-by-step processes are not important. I am starting with one of the most calculation intensive questions according to you. This compound interest should be a calculation oriented problem, normally. Let's see the GMAT approach to this first of all. Then we will see how to approach DS, but let's see this question. You are asked a specific value, is it more than 8%? How many variables do I have here? I have this value, I have, so interest is already there, this already is there, 1000, so on and so forth. I have the interest, and what is the only unknown I have? So will I get a particular value for the rate? That may be 5%, that may be 10%, that may be 8%. If the answer is 5%, I'll get a confirmed no answer. If the answer is 8%, I'll get a confirmed no answer. If the answer is 10%, I'll get a confirmed yes answer. So do I need to pick up the pen for the first statement? Tell me. Whatever, I am not supposed to check is it actually more than 8 or not. So long as I am getting a confirmed numerical value, I will always have an answer, confirmed no or a confirmed yes. So for the first statement, there is absolutely no need to calculate. Okay. Very, very crucial. You need to get this clearly in your head. What all is really required. You don't need to really calculate for the first statement at least. Now let's see the second statement. I am not saying what the answer key would be. How would you interpret the second statement in real life? Suppose your bank gives you, this is the formula we will use. How will you interpret the second statement in real life? If you deposit $100, in 2 years it will become greater than $115. Is this the meaning? Yes or no? In 2 years it should become greater than $115 if you start with 100. Perfectly fine. Now tell me, if your interest is, that means what is the interest in 2 years? Is greater than $15. Okay, if your interest is greater than 15 in 2 years, it can be 15.1 also. So suppose your interest is 15.1 and suppose your interest is 16, suppose your interest is 20 or 25. In 2 years, if your money becomes $15.1 extra, what is the rate of interest? Greater than 8 or less than 8? Less than 8, because 8 plus 8 itself would be 16. But in 2 years, if your money becomes $20 extra, then greater than 8. So it is confirmed. Is it greater than 8 or not confirmed? Now tell me, how much calculation did I do? This is supposed to be thought. This is not something that you write. This I am writing because I am supposed to explain. The entire thought process around math will have to change for you. This is what I am trying to explain. Extremely crucial, these things. I will explain it one more time what I did. We will come to data sufficiency and how to solve data sufficiency in some time. But again, if I have a fixed amount of interest that I earn in 2 years, I will have a fixed rate, whatever that answer is. 5%, 8%, 10%, 20% doesn't matter. I will get a confirmed no or a confirmed yes answer only. If the answer is 5%, then my answer will be confirmed no, that is acceptable in DS. If it's 8%, it will be confirmed no. If it is greater than 8, it will be confirmed yes. All of them are accepted. In the second case, we earn an interest of more than $15 in 2 years. That can definitely translate to a rate higher than 8% also, equal to 8% also, less than 8% also. So I will not get a confirmed answer. What is the answer then? If I say from the first one you will get confirmed yes, no, whatever it is. From the second one you are not sure. So what answer? A. Okay. If you do any amount of calculations in this question, then I said with the right approach you can solve it in less than 2 minutes. With the wrong approach you can definitely take as much time. You can actually calculate. You may even do root of 1 point whatever, square root of 1.15, and you may try to calculate what is the value. But then also you will make a mistake because you are supposed to take a square root of not 1.15, because this value is not 1.15, this value is greater than 1.15, so it could be greater than that. It could be 1.16 also, 1.2 also, 1.8 also. We really do not know this. So this was the whole idea about what I was trying to say. Now let's see, if I look at data sufficiency in general, how you will solve it. There are two types of questions. One type is what question, the other type is question. You have a question based on what and you have a question based on is. In a what question you must get a confirmed numerical value of the variable. It should be unique anyway. Numerical value, unique numerical value. In an is question, a confirmed yes is also acceptable. A confirmed no is also acceptable. And yes or no is not. So this is not sufficient. This is called sufficient. This is called sufficient. In a what question, if you get more than one values, then we'll call it not sufficient. If you can only get a unique value, then it is sufficient. Okay, I hope it's straightforward. You have to get a single value if you are asked what is the value. Now the first question that we had, is it a what or an is question? Is the rate greater than 8%? That is why we didn't need the exact value. But if you are asked what is the value of this rate or something, then you have to get the exact answer. Let's see if I ask you something like this. What would be your answer? Not the other one will not give you the right answer. Let's see. So this will give me x equal to -2. This will give me x is equal to 2, or you combine only when a particular statement is not enough and the other is also not enough. If one statement is enough or the other is enough, you never combine. So obviously first is enough here. So answer A here. Let's change this question and make it x cube equal to a cube and x square equal to a square. Now tell me your answer. Why C? Sorry? What did I change? Any other answer? I don't know, you're paying attention or not. I told you confirmed value, which is a numerical value. What did you write? Please check. One second. Confirmed which value? Numerical or non-numerical? Will I get a numerical answer? So the answer is E here. Your answer has to be a number, okay? Your answer can't be a variable. If I say what is x and you say x equal to a, this is not a solution. So E. Your answer has to be a specific number, not a variable. So E in this case. Let's say you are asked this is a recent problem, so it's not in the handout, but is P by Q a terminating decimal? I'll give you some time. You may not really know what a terminating decimal is off the cuff, but if you think a little, you will come to know. Now, on your own, you should be able to think of what a terminating decimal normally means. B. Okay. Take some time, please. Try to solve this problem. Okay. How do you decide whether a decimal in the form p divided by q terminates or not? Let's see. If I write 1 by 1, 1 by 2, 1 by 3, 1 by 4, up to 1 by 20, let's say, just randomly to understand what is happening. 1 is terminating, 1 by 2 is 0.5, that terminates, 1 by 3 is up to infinity, 0.333 up to does not terminate. 1 by 4 will terminate, 1 by 5 will terminate, 1 by 6 will not terminate, 1 by 7 will not terminate, 8 will terminate, yes, 9 will not, 10 will. Again 11 won't, 12 won't, 13, 14, 15 won't, 16 will. You write 1 by 16, it will terminate or not? 17? No. 18? No. 19? No. Again 20 will terminate. So now let's see which all are actually terminating. 1 by 2 is terminating, 1 by 4 is terminating, 1 by 5 is terminating, 1 by 8 is terminating, 1 by 10, 1 by 16, 1 by 20. And so on, 1 by 25 will terminate. What do we derive? Even if you don't remember math at all, you can think about it quickly. So what is the condition that a decimal will terminate? The denominator is made of only either 2 or 5 or powers of 2 or 5. If the denominator is made of only 2 or 5 or their power combination, then the decimal will terminate. Otherwise it will not. Can I guess something like this by doing this work? If you are not sure. Anyway, you would have been taught later. It's not a question that you will suddenly get. But let's see. Now let's come back to this. P is a factor of 100. So 100 is made up of what all? Let's see, 100 is what? 2 square into 5 square. It's totally made up of 2 into 5. Again 2 square into 5 square. Tell me what all factors are there of 100? 1, 2, 4, 5, next 10 and 100. Okay, these are the factors. Each of them is either a power of 2 or a power of 5 or a combination. Can I see that clearly? Now tell me, in deciding what will matter, the numerator or the denominator or both? Denominator only or numerator? Okay, so math wise you are thinking correctly. But imagine if P equal to 1 by 3 and Q equal to 2, then what will be my answer? 1 by, this is non-terminating. So the answer will be, you might say, but how do you know this P is 1 by 3? Exactly, that is why you need this one. So all of you gave the answer as B, which is mathematically logical, but there is an assumption you made which you should not have made in the first place. What is the assumption you made? P is an integer. You cannot make that assumption, please. If you make that assumption, you will get the wrong answer. So the answer is C here. Okay, imagine P equal to 1 or 2 or 5 or something, then it's all right. 2 by 2, 2 by 4, 2 by 5, 2 by 100, etc. All of them will terminate. But if P is equal to 1 by 6 and Q equal to, let's say, 1, the problem is I need to know whether the numerator itself is an integer or not. So maybe in 10 seconds when you guessed it, you just need to take, I told you don't do a question in just 10 seconds. Just take your time. It's 2 minutes that you allotted, at least a minute you should take. Think of all the possibilities. Now when has this mistake occurred? Imagine I asked you to watch my video, which is 10 questions, out of which 5 talk about the same trap. Don't assume it's an integer. Yes or no? And then you already solved this, in which so many questions actually have the same trap, and once again the same trap will fall into it. So there is not much that math part is really difficult here. It's not really math. It's just this. Any doubt with this? If you have any doubt, Before I move on, tell me anything that you have not understood in this question. Anyone? Raise your hand and ask, please. Don't bother whether others have understood or not. Okay, that should not be a concern. Anybody not following what I've done? Okay, if I don't read the first statement, that is P is a factor of 100, then I can take any value of P I want. Can I or not? You are not given P is an integer. Had that been given, what is the answer? B. Okay, that's straightforward B then. Absolutely no doubt. That's B. So this is the only problem that data sufficiency poses. From that perspective, whenever you are given a what question, you must get a unique and a numerical answer. If you are given this, a confirmed no will also be fine. Let's see some more problems. In your handout, let's solve these questions one by one. So question number 2, what answer did you get for this one? B. How to think on this question? Okay, so don't bother about your accuracy. This is the first session in math. As you saw last time, your RC accuracy turned out not so good, but after just one, I told you in 1 week it will improve, and beginning I think everybody told me RC is improved. So definitely this will happen for math also, but just if y is greater than or equal to 0, can I say y can be 1, 2, 3, 4, 5, anything? Anything. Let's just take randomly. I am saying how easy it is to solve this problem. If I take y equal to 1, 2, 3 and substitute it here, let's put it 1 or 2 or 3 in this one, then can I have multiple values of x or only one value of x? This automatically means mod of x minus 3 equal to, let's say 1, mod of x minus 3 equal to 2, x minus 3 equal to 3. I'll get various values of x. What is the condition? The answer should be unique numerical. So this is not sufficient. Without doing anything, you know the answer. This cannot be sufficient, because if I take various values of y, 1, 2, 3, I'll surely get various values of x. Some doubt? You seem to be having some trouble. Tell me. But what is the value of mod of x minus 3? It could be 1 also, 2 also, 3 also. If I solve that equation, can I not get different values of x? Right? It's greater than 0, so I can assume mod of x minus 3 as 1, as 2, as 3 and keep solving it. Will I not get different values? Look at the equation that I have written on top. Can I get the same value of x each time? This thought should be there very quickly. So this should be understood clearly. I don't think there is any concern you will have with respect to if you. Now think about it this way. What is the only condition for any absolute value or mods? It cannot be negative. So it can be either 0 or positive. If I substitute y equal to 1, 2, 3, what will be minus y? Minus 1, minus 2, minus 3. Mod of x minus 3 is less than or equal to minus 1, minus 2, minus 3. Is it possible in math or impossible? So for the second statement, y equal to 1 will make it mod of x minus 3 is less than or equal to minus 1. It can't be equal to minus 1 also. Both are wrong, because the definition of mods always tells you that they cannot be negative in any case. But can I substitute 0? Y can also be 0. So I can surely say mod of x minus 3 less than or equal to 0. I can still break it into two parts. What are the two parts I know? Mod of x minus 3 less than 0, or Again ask yourself, is it allowed in math that it is less than 0? So this is again invalid. This is invalid. So the only thing that is valid is this, and this will give me x equal to 3 only. So considering all possibilities, the second statement can give me only one value of x, and that is x equal to 3. And that is why the answer has to be B. I'll give you a couple of minutes to understand what we have done in this question, because on a fresh sheet try to just do the whole process in your mind. I hope nothing is confusing, because this is a very, very crucial concept. Yes? No, that's different. But first of all, when you take out the mod, you can't do this. You just can't directly do that thing. No, in that case, you have to take the negative side and then change the sign of the inequality. But first condition, if y is positive, then mod of x minus 3 could be greater than 1, greater than 2, greater. So I can have how many values of x? That is my question. How many values of x can be there? Okay, you got x is greater than or equal to 3. How many values of x exist now? So then that's it. It's not enough. The moment you say infinite values, it's not enough, right? It's wrong. This approach is not good. Yes, the sign has to change. Yes. Yeah. Exactly, it will. Now substitute the values of greater than or equal to 0 means which all values? It could be 1. Mod, just don't change that thing. Just what is the meaning of greater than or equal to 0? It could be 0, it could be 1, it could be 2, it could be 3. So if I substitute different values, will I get a unique value of x, or will I get different values of x? The moment you say different values of x, it's not unique. The moment less than or equal to 0. But that is the whole point. When you say what do you mean by greater than or equal to 0? Can it be 1 also? Why are you thinking of that as 0 only? Greater than or equal to 0 means 0, 1, 2, 3, anything. That's the mistake you make. You can't plot this one on a number line. This is an open-ended graph. No, that's not correct. I'm sorry. I'll just explain it to you. Yes. I'll explain it one more time. Let's see. I can understand. That is why I gave you some time. If mod of x minus 3 greater than or equal to 0 and y is given as greater than or equal to 0, that is for the first statement. What all values of y exist here? I can break this into two parts. Okay, this means either mod of x minus 3 is equal to 0 or mod of x minus 3 greater than 0. What all values of y are there? It could be decimals also, but let's take only integers. Okay, let's substitute, greater than or equal to y. What is this 0? Y, What is written in this first statement? Greater than or equal to y. So let's put it equal to y here. If I substitute y equal to 0, what is the value of x I'll get here? X equal to 3. If I substitute y is equal to 1, what is the value of x I'll get? Mod of x minus 3 equal to 1 now. I'll get two different values of x. I need not bother what they are. I'll get two more values of x. If I substitute mod of x minus 3 equal to 2, I'll get another two more values of x. You can't do the calculation. There is no need to do anything in this problem. In 10 seconds, you should be able to solve the entire problem if you know the concept. Is this clear or not? When you take various values of y, you will get various values of x. Is this clear, sir? I don't even have to go up to this level. You can say, okay, this one will give me even more number of values. So forget, this one is definitely not sufficient. Should take you maybe 5 seconds to guess. No paperwork required for this. You don't have to pick up your pen for this one for sure. Okay. The second statement says, let's put it this way, mod of x minus 3 less than or equal to minus y. Let's break it into two parts first. Mod of x minus 3 equal to minus y, or mod of x minus 3 less than, what is the value of minus y? Is 0 or, because what would have been the value of y? Y would have been 0, 1, 2, 3. So minus y is this value. Let's substitute mod of x minus 3 is equal to 0 or mod of x minus 3 equal to minus 1, etc., etc., etc. This is not defined in math. It's impossible. Minus 2 minus 3 is impossible. So the only value of x is equal to 3 from here. In this case, mod of x minus 3 is less than 0, less than minus 1, less than minus 2. Is it possible in math or not possible? This is impossible. So the only answer is x equal to 3. Again, you should be able to think of all this in less than 30 seconds. I am not saying take only less than 30 seconds. You may re-verify, you can do all of that, but still, this is the approach. Any doubt still? Some doubt? Any questions? Yeah. 15, greater than $15. Yeah. How do you know? It could be 15.1 also. That has to be known to you what the value is. If I take $15.1, then my rate will come out less than 8. What is 8 plus 8? 16. Anything less than 16 will give me less than 8. Anything greater than 16 might give me greater than 8. Do you understand this? Sorry, tell me what the doubt is. Did you follow or no? And that's it. If you got to bother about why, because exactly. So, but that depends on why. Exactly. If it is greater than 0, then what value will you assign it? Is it greater than 0? Does it mean one value or can be any values? That is it. If x can be any value, then x cannot have a unique answer. Right or not? The moment you say any value, what does that mean? Can't have a unique answer, can have a unique answer. Okay. Think about it. It's very, very simple. Yeah. Yeah. That's not enough. No, that's not enough. Any doubt still? Let me know. Anyone having any doubts still? Okay. Fine. Let's see some more problems. Alright, so let's see. On the number line is 0 halfway between R and S. And the first statement says S is greater than 0 to the right of 0. Second, distance between T and R is the same as distance between T and minus S. Let's see. What is the answer you got? B. Alright. Let's see how to approach a problem like this first. The first statement says S is positive. It doesn't say anything about R. R could also be positive. R could be negative, R could be 0, R could be anything. So we have no clue from the first statement, and I'm sure in a second you know that it is not enough. Second statement, distance between T and R is the same as distance between T and minus S. Now from the first statement you can take a cue. S is positive. What if S is negative? So I should consider both scenarios. So from second statement, situation number first and situation number second, I'll consider differently now. If I say if S is positive, in that case distance between T and R and T and minus S is the same. Suppose this is where this is 0, this is S, this is T. Now T and R and T and minus S. So if S is positive, minus S has to be. That means R also has to be here. Distance between T and R is the same as distance between T and minus S. So can I say in this case R equal to minus S or S equal to minus R both? Right? They have to be basically of opposite signs. That means is 0 halfway between S and R? What would be your answer? Yes. So in this case the answer is yes. Now let's take another scenario in which S is negative, because you can't assume S is positive and then start. That is given in first state. So let's assume this is 0, this is R, this is S, this is T somewhere. And T can be anywhere, positive, negative, doesn't matter. Let's take some random values here. Let's take T as minus 1, S as minus 2, let's say. So what will be minus S now? Plus 2. So distance between T and R is the same as distance between T and minus S. So T and minus S, right now the distance is 3. If I want the same distance 3, then R should be minus 4. Now ask the same question. Is 0 halfway between R and S? What is your answer? If you get one yes and one no, overall it is not sufficient. If it is not sufficient, then the next thing is, first was not sufficient, second is also not sufficient. Next thing is obviously to combine. If you combine and say S is positive, if S is positive, then which situation is out? So what is the answer in this case? Yes, and C is what you must mark. I'll give you a while to assimilate what you understood. Let's see. Any doubt anywhere, ask me again. This is an extremely important concept building session. I'll take it very slow, but it's crucial for you to see how data sufficiency can completely trap you if you don't. And if you think right, it's not difficult at all. You will see in 1 week your accuracy will jump quite a lot. Start thinking about the traps. Any doubt of any kind, please? Yes. Sorry. In which case? They are saying distance, so I don't have to say anything. They are saying distance between T and R is the same as distance between T and minus S. But you have to figure out which side minus S will be. Minus S could be this side or this side depending on what S is. If S is positive, then minus S is negative. If S is negative, then minus S is positive. So I'll have to take both possibilities. Exactly. Absolutely, you can. Yes. Did you get the answer by that? Yeah, perfectly fine. That's correct. Any doubt on this one, please? Keep asking. I'm saying again and again, I'm encouraging you to ask your doubts and don't bother about others who are not following or following. Please think about it. Anywhere? Yes. Yeah. I mean, I just started with minus 1, minus 2. You can take minus 200 also. It's basic, doesn't matter. Yeah. It's okay to assume because I have not been given anything. You can do it 0, you can put on the T could be positive as well. T could be plus 1 also. It makes absolutely no difference. Take T as plus 1, S as minus 2, let's say. plus 1. Yeah. So take it as anything. Let's take it plus 1 here, minus 1 here. Okay. What is the distance? The distance between t and no. What is minus s here? No. So then you have to do minus 2. You can't have the same value. So it will go to plus 1. Yeah. And what? This is the distance. What is the distance between t and minus s here? 1. So if I say distance between t and r, you can't be the same. So 0 won't be in between in that. What is the question? Is 0 between? No, not in this case, not. Where are we stuck normally? Tell me. I'll explain it again. Anything. Okay, what mistake were you making when you solved this problem? That's more important. You did not assume the second case. What mistake? You got it wrong. Okay, no carry forwards. You can't say S is positive, so it is applicable to statement 2. That's a disaster. Okay? So you can't do that really. Any other thing that you were doing wrong in this case? Sir? Yeah. I am not given anything about S. So I can take anything anywhere I want. I can take some of them positive, some of them negative, I can take all of them negative. I am just taking random values minus 1, minus 2 because that's the first two values I'll think about whenever and the moment distance between t and minus s is to be considered, that comes out 3. From t I'll go 3 in that direction and put r as minus 4. And I'll get the answer as no, 0 is not in between r and s. That's it. It doesn't mean these are the only values. You may put whatever values that come to your mind. In DS, what are we looking for initially? We are looking for one yes case, one no case always. The moment you have one yes, one no, should you proceed or that statement is over after that? It's over. Because in that case, it's not sufficient. So don't need to go on after that. Okay, let's see. Question number 4. So you are given y is equal to x plus mod x, and in the first statement you are given x is negative and y is less than 1. What all are you given apart from that? Y is in integer. So and is y equal to 0? Number 1 and number 2. The first thing that you need to realize in a question like this is that y depends on x. So all values of x that you can think about should be part of your range. So x could be either negative or 0 or positive. When x is negative, y will always be. When x is 0, y will be 0. When x is positive, y will be. So that means, okay, have I considered all values of x or not in the entire number universe? It may be different values, but finally I have considered all the values of x and I get y is either 0 or positive. That gives me one very simple conclusion: y cannot be negative. Is this before going to statement 1 and 2 or after going to statement 1 and 2? Whatever we have done right now. This is before I have gone to 1 and 2. Now the first statement says x is negative. Obviously y is 0. So it is sufficient. Second statement says y is less than 1. What else do I know about y now? Y is integer. And what is the other thing? What is the value of y now? Less than 1 means 0, minus 1, minus 2, minus 3 and all the negatives are cut. So only thing that remains is 0. No, it's asking you, not say. Yeah. Yeah. Clear, right? Let me know your concerns. Okay, so what is the thing that you may miss here? Please tell me. What is it that you may go wrong with? Must have happened, I'm sure. You're not telling me now, but I'm sure. What went wrong in this one? Went wrong or A, right? A is the answer most often you will choose. What's the problem with the second statement that you missed basically? You missed y is an integer. Even if you remember y is an integer, if you don't prove y can't be negative, it will still mean the same thing. Nobody can say this question is difficult, really speaking, but yes, it can go wrong. Let's see, question number 5. What answer did you mark for this question? E. Otherwise, A. Any other answer? E. Alright. The correct answer is E. I'd like you to take some time and tell me how this answer comes. You have to get this answer on your own now. I have given you the key. Let's see how it works for you. Are you able to get E or no? Get the answer. Or were you still thinking A is the answer initially? So let's understand, there are a couple of things to take away from this. I gave you this time because otherwise this question may be clear to you, but the whole idea of data sufficiency, how to approach, is not very clear. Whenever there is an is question, we are essentially trying to prove one yes situation, one no situation. In your mind, you have to start with the idea that I am thinking about how can I get a yes and a no, rather than trying to get a yes, another yes, another yes, another yes, and say that okay, that means it's sufficient. It's a bad start. Okay, maybe there is one value after this that proves a no. Did it happen in that factorial question, by the way, that there was a question on factorial or something? If you watched it, that after, at 2 it proves yes, 4 it proves yes, 6 it proves yes, 8 it proves no then. So that's a very bad approach, that I try to prove only a yes. Similarly, a no approach is also a bad idea. Maybe something else comes out yes. So the best idea is, from my own side, I should try one yes, one no, and it works perfectly. Let's see how it works. Okay. So if I have to say the first statement is true, let's say, on the basis of this, the main question's answer can be a yes also, can be a no also, if this is possible. And if the second is again taken as true, the main question's answer, I am writing it very clearly so that later in terms of a graphic it is there in your head. I can get a yes also, a no also. Okay, now suggest some values that will satisfy the first statement. Please suggest some values. 1 1 1, can I say? Very simple, random 1 1 1. And then check, do they satisfy the main question or no? So answer is yes. Now your job becomes very difficult when you have to get this yes but this no. What am I asking you again? Think of some values that will satisfy the first statement but that will turn a no for the main question. Sorry? I didn't understand, sir. The answer to the first statement should be yes, but the answer to the main question should be no. 2, 3, 4. 2 square plus 3 square is not greater than 4 square. I should satisfy the first statement but not the main question. Okay, first thing, statements are always true or false? Statement 1 and statement 2 are taken as true or false? True only. So there is no, this can never be no here. Okay? The only thing that can go yes, no is the question, not the statement. Alright, now tell me some values that satisfy the first statement but don't satisfy the question. 4 square plus 5 square, is it greater than 6 square? Yeah. 4 square plus 5 square is greater than 6 square. But 4 to the power 4 plus 5 to the power 4, is it greater than 6 to the power 4? Not sure. No, you can do 4 to the power 4, 256, 5 to the power 4, 625, 6 to the power 4, 1296. So what is the, it is, so 456 is one answer, and he's right. If you take 456, but 456 will be too much calculation. Imagine 6 to the power 4 for you. It will be much more. So okay, one is surely 456. And when you say 456, you should first check 4 square plus 5 square should be greater than 6 square. That is happening. Yes or no? Yes. And 4 to the power 4 plus 5 to the power 4 should not be greater than 6 to the power 4. That is also happening. So give me some other pair, because this will be, how do you know this is satisfied and that is not satisfied? Yes. Will that satisfy? Yeah. Perfect. That will satisfy. So that could be one. You can take some other value, 3, 4, 5, 4, 4, 5, let's say. How to get this, because this will be your biggest concern. Fine, randomly someone said something among these many people and one, this is alright, but how do we get it? What is Pythagoras' theorem? X square plus y square should be equal to something like that. What is the first triplet that satisfies Pythagoras theorem? 3, 4, 5. But 3 square plus 4 square is exactly equal to 5 square. You want greater, so 3, 4, 5. Make it slightly bigger on the left hand side, make it 4, 4, 5. So you are guaranteed 445 is a good triplet to experiment. Let's do that exercise one more time. 4 to the power 4, sorry 4 square plus 4 square, is it greater than 5 square? 16 plus 16 greater than 25, yes. 4 to the power 4, 256 plus another 4 to the power 4, 256, which is 512. 5 to the power 4 is 625, is it greater? So clearly, now tell me, is the first statement enough or not enough? If I get one yes, one no, it is not sufficient. So the first statement is not sufficient. Statement number 2. Now, very rarely can this happen, but this is happening in this question, so you should exploit it. Can the same values 1, 1, 1 and 4, 5, so whatever, be used for the second statement? Second statement is x plus y greater than z. So the second even this will become not sufficient. 1 plus 1 is greater than 1, but 1 to the power 4 plus 1 to the power 4 is not greater than 1 to the power. Combination will not make any sense, do you agree here? Because the values remain the same. Even if you combine, can I get different values or the same values? Suppose I say I combine the two. Can I still use this value and this value? So finally, even on combination, 1, 1, 1 will give me yes and 4, 4, 5 will give me no. So final answer E. You can. Exactly. So that is what we learn in inequality session. This session is not on inequalities. This session is just telling you data sufficiency, how to approach. So is the logic of DS clear? How to pick these numbers is a big problem a lot of times, and the best solution is, one is an obvious set of numbers. The other is, if you keep this in mind, that I have to take this always as yes, but that as yes and no both, some set will emerge. In this case, the biggest way, according to me, I would have picked it up that okay, x square plus y square is greater than z square. So somehow Pythagoras theorem comes to my mind. I am not sure. It should come. It will come in fact in some time. It will start happening. And then you say 3, 4, 5 won't work, so 4, 4, 4, 5 might. That's yes. I'll combine it. Again the same values will come. Yes. Okay, if I combine, then I have to say this should be satisfied and this should also be satisfied. Even then, the main question can be yes and no both. That's This is in which case you got lucky that the same values are satisfying for both statements. May not happen all the time. Okay, please tell me your challenge here. Anywhere. I can understand it is a little disheartening so far. Yes or no? Yes. No, not at all. X square cannot be negative. Not at all. On GMAT, no. X square will only be positive. Only and only. No negative values for x square.
So, like, at what point do you stop searching for answer? Like, you keep getting as like, when?
No, but your mindset has to be you don't have to keep getting this. So you have to start thinking in a no way as well right from the beginning.
Like, what if you're trying to think of a no? And get a no.
Then you have to prove, then you should prove algebraically that it is yes only, not numerically. Okay, so there is another thing. Why are we substituting values? Why are we not solving by algebra? Because that's one more favorite approach that you have. Algebra is not trustworthy as an approach in GMAT at all. If you use algebra for most of the data sufficiency questions, whenever you have yes, no, you might miss out on something. Okay, algebraically, what was the answer to P by Q question? What was the answer? B, right? I told you. In this question, I am guaranteeing you, if you think only algebra, 99% of the times people will answer A here. So algebra, you may be very good at math, but I will still say just substitute. Doing algebra alone is a bad approach. You will not be sure of your answers. So start thinking in terms of number plugins, not algebra alone. Okay. Let's see. Question number 6. What is the answer you got? Yes. You may see. I get a yes and no already. That's all. My point is, I've already got one yes, one no. Then I should not take anything else. If you keep getting a yes, please keep experimenting. You can't stop. But if you get one yes and one no, you need to stop there. Question number 6. What was your answer, please? C. Any other answer? D. Any other answer? A. Alright. Let's see what to do. So you have P divided by M. What is the remainder? Is the remainder greater than 1? There is a difference between these two questions. What is the remainder versus is the remainder greater than 1? So let's be very clear about this one. Now the greatest common factor, or GCF or HCF, highest common factor, is 2, which simply means both the numbers have to be even or odd. Even numbers. Now one even number divided by another even number. When the two don't divide fully, it is written M is not a factor of P. So it's like 6 divided by 4, 8 divided by 6, 10 divided by 6, 10 divided by 8. They don't cancel out fully. What will be the remainder? More than 1 or 1 only? 6 by 4, the remainder is 2. 8 by 6, 2. 10 by 6, 4. 10 by 8. So the remainder will always be greater than, because remainder will be an even number always. It cannot be 0 because M is not a factor of P, which means remainder is not 0. So you are guaranteed that the remainder is at least 2. It could be more than 2, 2, 4, 10, anything. Is this fine? HCF is the common factor, so both the numbers have to be even. So the first statement is definitely sufficient. Let's see the second statement. If you look at the second statement, the least common multiple of M and P is 30. So the LCM is 30. Give me some combinations of two numbers, and don't think they have to be even now. This is out. Don't think of statement 1. Two numbers whose LCM and both the numbers are greater than 2. So how many numbers can I write? 1 and 30? That is not going to work because both numbers are greater than 2. 2 and 15, 3 and, this will work. Any other combination? So P divided by M will be 10 by 3. Remainder is, okay. Now there is a catch here that will come to later. Right now if the remainder is 1 only, and what is your question? Is the remainder greater than 1? What is the answer? Confirmed? No. This is a big problem because the DS theory says the two statements cannot contradict each other. What was the answer from the first statement? Yes. And from the second statement we got no. That means we have made a mistake for sure. What did I tell you in the first? If you read the theory, is it given the two statements can't contradict each other? So from the first statement if I get yes, from the second statement either I should get only yes or I can get yes, no. But I can't get a no. Okay, let's think further what mistake we may have made. If the LCM of two numbers is 30, can the numbers only be these or can they be other possible? 6 and 10? What is the LCM of 6 and 10? Please tell me. 6 and 15? 10 and 15? Now the remainder is 4 here. Remainder is 3 here. Remainder is 5 here. So the remainder can be 1 also and can be greater than 1 also. We are not sure from the second statement. So the answer is A. One important learning here, the two statements cannot give me contradictory results. That is how you are taken back to the question. Yeah. P is bigger than M. That is given in the. Any doubts, please? I need to once again tell you because I know what you would be feeling as of now. Please, if you've done these questions for the first time, don't lose heart. You'll see a radical improvement in just 1 week. It's just the thought process change. Is it also telling you that these questions are not difficult if I just be careful? Or is it telling you these questions themselves are very challenging? What is the message you are getting? Be careful. That we may learn. So don't lose heart. I can sense the kind of activity we had in the first half an hour. It's all gone right now. It's all silence. What happened? Please participate, understand, and don't feel so bad about it. It's okay. It will come. It will come in some time. Okay, the seventh problem. Let's see how to approach that one. xy plus z is an odd number and xy plus xz is an even number from the first statement. And your asked, is x an even number? I can subtract the two. What will be the subtraction? Let's say xz minus z, I can take z common. xy and xy will cancel. xz minus z is, take z common, x minus 1, which will give me even minus odd is. Now the two numbers product is odd. That means each of them should be. That gives you x minus 1 must be odd. That tells you x has to be even. So the first statement is definitely sufficient. Subtract the two values. Xy minus xy is 0, xz minus z is z times x minus 1. Even minus odd is odd. Product of two numbers is odd. Both numbers have to be odd. So z is odd and x minus 1 is odd. If x minus 1 is odd, x is even. Alright. Looking at the second statement, do it exactly in the same fashion the way you. Yes, please. Even minus odd. Okay, subtract the two. That's it. X. So 2 minus second minus first. So xy minus xy will be 0. What is xz minus z? Take z common. X minus 1. Even minus odd is going to be odd or even? Any even number minus any odd number. Odd. So that's what. Yeah, so something has to, some mathematical operation needs to be done. If I combine two equations. Yeah, then you can do the table form, but it will be longer. It will be much longer. Yeah, you can do that too. No problem there. Okay, let's see the second statement. Can you do something about the second statement in the same fashion? What is given to you? Let's see. In the second statement, what is given? Let's see. The main question doesn't change, but the second statement, let's see what is given. Y plus xz is odd. Now it is totally up to you whether you add or subtract. You should decide what will make more sense here. Subtract is also fine, add is also fine. Totally up to you. What makes more sense? You may do anything you want. This is mathematically it's okay. So xy plus y, I can take y common, and that will be x plus 1. Again, I can take z common. So what will this be? X plus 1 into is equal to odd plus odd is even. When the product of two numbers is even, this could be even, this could be even, this could be odd, this could be even, this could be even, this could be, which means x plus 1 could be even also, and so x could be odd also and even also, and this is not sufficient. What? What? You finally got one. Okay. How are you doing here? Making sense. Not tough, right? Just missing something. How is it going? क्यों ऐसा क्या हो गया? But do you realize it's not, you're not too far off from the right answer? How's it going? Hmm? That's okay. Yeah. Making sense, but yes, please. Odd minus odd is even. Sorry. Okay. What are we doing? Which first statement or second? This is first. Yeah. So odd minus even is odd. Odd plus even is also odd. So that's why odd. One minus x. Okay. You can subtracting one to one from. Sorry. One minus two. You're doing. I did two minus. It's one and the same thing. If 1 minus x is odd, then also x is even. Then also x is even. Doesn't matter. Okay, do it. What are you doing? Xy minus, sorry, it's not written. Just do either way you. Yeah. Zero is even. It's neither. Zero is an even number, but not positive, not negative. It's an integer, but not positive or negative. Let's do the first statement one more time. I think there's some concern there. So let's see. Xy plus xz is even. You may do whichever first minus second, you may do second minus first. So let's say xy minus xy would give me 0. Z I can take common into odd minus even is this, and this individually should be odd and odd. If 1 minus x is odd, x is going to be, has to be even. There is no other way you can get. Don't think only 2 is even. Plus 2 minus 2 0, both are, all of them are even. So it doesn't matter what it is, but clearly this has to be the answer. Okay, let's see question number 8. Just for your convenience, just assume a minus b equal to x, suppose. Convenience issue. So what is your question? Is 1 by x less than minus x? It's out of convenience that I am writing a minus b equal to x. Now there is one more thing that you need to learn here, very very crucial, and that is, if you can simplify the question, always simplify it as much as you can before you go to the statement. What is the meaning of this statement? When will this happen? 1 by x is less than minus x. When will this happen? X is positive, x is 0, x is negative. You tell. Negative only, right? All, if x is positive, this will be in positive less than negative, impossible. X is 0 is not defined in this case. X is negative, what do you think? If x is negative, 1 by x is also negative, and minus x is positive. All negative numbers are smaller than all positive numbers. So what is the meaning of this statement? Please tell me. What is your question? Is always better to simplify the question before you move forward. What is the first statement telling you? A less than b means a minus b less than 0 means x is less than 0. First says x is less than 0, which obviously means x is Negative. This was your question. Yes, only. So this should be sufficient. Statement 2. 1 is less than mod of x. That means mod of x is greater than 1. If mod of x is greater than 1, x could be only positive or can be negative also? Can be negative also. X could be 2 also. X could be minus 2 also. So x can be both positive and negative, and we are not sure. And A is your answer. If 1 by x is less than minus x, there are 3 values of x that you can consider: negative, 0, positive. Try to substitute a negative value. What will happen? Is negative less than positive? What is the answer? Yes. So what is the meaning of this? X should be negative. Just try to see. There are only 3 possibilities: x is 0, x is negative, x is positive. X0 is impossible in this case because 1 by 0 is not defined. If x is negative, this will be negative, this will be positive. So this is obviously okay. If x is positive, this will be positive, this will be negative. Positive can't be less than negative, this is not right. So the interpretation of the question is x negative? Any concern here? Okay, let's see. Question number 9. What answer did you get for this problem, please? Okay. How do we solve a problem like this, which is one statement is so easy and obvious, the other statement, let's see. This value has been given to be. So if you have 5 and 13, by Pythagoras' theorem, that this value should be. So the first statement is definitely sufficient. Absolutely no doubt there. I'm sure you don't need any explanation for that. Pythagoras theorem, straightforward, 10 seconds you know that. When you look at a triangle whose base and height are, let's say, perpendicular 5 and 12, and this is 13, the area of this triangle comes out to half of. So for 5, 12 and 13, area is 30, and it is a right angle triangle. Now remember one thing, when you are given the second statement, what is not given to you? That is 90 degrees. But you also know that area is 30. So now we knew that 5, 12 and 13 the area is 30, out of which 5 is known to me already, 13 is known to me already, area is 30 is known to me already. What should be the third side? Please? You don't want to answer now. Say something. Hero's formula means 12 only or something else? Only 12 or other? Hero's formula surely can be applied. My question is not that. What do you think right now? Will it give me? Can have 2 values? Can it have 2 values? Okay. With 5, 12 and 13 the area is 30. How many things are there? 3 sides and 1 area. Out of which I know 3 things now. The only thing that should be, so should it be 12 only or should it be something else? How do you decide now? Yes. I'll give you some time. Please tell me, if the 2 sides of a triangle are 5 and 13 and the area is 30, what should be the third side? I don't know any other value, 90 degrees or anything. Will you get one answer or will you get more than one answers? How do you say that? You may do what you want. That's totally up to you. Okay. Absolutely right. Okay. So let's see. No. But will the area be 30 always? 0 to 90, any angle and the area will remain the same? No, but will it give me, I can keep the changing the angle, will I get the same area? No, never get the same area. Okay, so let's see what we are doing here. Let's say the 13 value is your base and one of the sides is 5. And I am not sure where to keep it, so let's say one side is 5 here. And I don't know about the third side, anything, and I want this value. And I know the area is 30. So half of base into height is 30. So half of 13 into h is 30. So h comes out 60 divided by 13, which is slightly less than 5. Which is obvious, if this side is 5, the height has to be less than 5 or more than 5? Less than 5. So the exact value of the height should be 60 by 13. And I'll definitely get this as the third side. But if I take this value, this particular side, if I rotate, this I keep fixed and this value I rotate. Can I get this also as a possibility? This is 13, this is 5, drop a perpendicular from here which is exactly 60 by 13, and then this is the third side. Is this possible? What is the area in this case? Please tell me. In this case, what is the area? Obviously again. So the third side will have two values. One will be 12, the other will be much more than 13. It's in front of you, I have just done it in front of you. Then I'll tell you a very simple way to do this problem. First, convince yourself this is possible. Sorry? You got it correct. Very nice. Yes. Now there is another way to look at this problem. Is this clear, first one? But as I also said, you have less than 2 minutes to solve a problem, you can't do all this. Yes. What is the doubt? If 13 is the base, I have made 5 this side and 5 that side. That's it. Graphically, can I make 60 divided by 30? Is it less than 5 or not? So, somewhere, if I keep rotating this end, somewhere 60 by 13 will come both sides. If I keep rotating this side, will I get 60 by 13 both sides or not? That is where you have to stop, this side and this side. There are two triangles and the third side will change. What's not clear? Tell me. Is this triangle clear or not in your case? 60 by 13 is clear. Height. What is 60 by 13? Less than 5. If this value is 5, I have to drop a perpendicular which is less than 5. So I just have to rotate it and exactly stop at 60 by 13 value. Both sides. This is the height of the triangle. This is also the height of the triangle. That's one way to look at this problem. First of all, at least you should be convinced that this is happening. But there is a much simpler way. If you are given two sides of a triangle AB and you are given that the included angle is, let's say, theta, what is the area of this triangle? Half AB sine theta. So let's apply half of, what are the two sides? 5 and into sine theta, which is equal to 30, that is given. What is sine theta going to come out to? 12 by 13. If sine theta is less than 1, you don't have to know trigonometry at all. It's just for theory, I am proving it. In that case, you can remember. If sine theta is less than 1, theta is in which all quadrants? First, second, third, fourth. First and third. What is sine 150 degrees? Positive or negative? Forgotten. Never studied maybe. That's better. Okay, it's always in first and second. What does that mean? One value of theta will be an acute value, the other value of theta will be an obtuse angle. That's it. If sin theta is positive and it is not 1, then there are two values. This is another proof why it will have two values. But it doesn't mean you need to know sin theta at all. All you need to know is if two sides of a triangle are known to me and the area is known to me, then the third side will have two values. Remember only this much in theory. If two sides of a triangle are known to me and the area is known to me, then the third side can have two different values. There is one more way to solve this problem. You said Hero's formula, so let's apply Hero's formula. Okay. This is given to you as 30. A is given to you as 5, let's say. B is given to you as 13. C you don't know. So how many, can I say this will involve C, this will also involve C, again involve C, again involve C. So which degree equation is this? Fourth degree equation. Now one root is also obviously known to us, that is going to be equal to, we have already seen that, this is guaranteed. A fourth degree equation can have all four real roots or two real roots or zero real roots, because imaginary roots occur in pairs. So how many imaginary roots can you have? Either zero imaginary or two imaginary or four imaginary. But four imaginary is impossible because one real we know. So how many real roots must be there? Minimum two real roots. So this means one real root. So it cannot be one real and three imaginary. That doesn't work in math. So if it is one real root, it has to be two real roots or four real roots. Because zero imaginary is okay, two imaginary is okay, four imaginary. But one imaginary and three imaginary roots don't exist. So what does this tell you? How many values should be there? Minimum two. I don't know, two, maybe four also. Minimum two values have to exist for the third side. Alright, so you don't have to do any of the three methods. All you have to remember in one line is if two sides of a triangle are known and if the area is known to me, the third side has two different possible answers. If you had known that concept, how much time do you think this will take you? 10 seconds maybe, right? The entire question. That's what. Okay, let's see the 10th problem. Okay, let's see. Whenever you are asked a question like this in which an overlap is possible, there is a different approach I'll tell you that you follow all the time. Don't really try to follow different approaches. Don't follow Venn diagram first of all. Venn diagram is only for three variables, not for two. So follow a tabular approach. If you take A here, take A's complement here. If you take B here, B's complement here. Don't mix A and B and A complement, B complement. A's complement, B and B's complement, always. So there are two groups here, Japanese and French. So let's take French and French complement, Japanese and Japanese complement. You will automatically get the answer if you follow this approach. There will never be a problem at all. If you do Venn diagrams, there is always some confusion that can be there. So at least 100 students study Japanese. This value Japanese is greater than or equal to 100. Don't call it 100. Okay? At least 100, can be more than 100 also. 4% of the students who study French, so suppose this value is x here, 1 second. What is the value? 4% of those who study French also study Japanese. So French and Japanese is this value. 4% of this will be 0.04x here. Okay. Do more students study French than Japanese? That means, what is your question? Is x greater than y? Is this the question clearly? Alright. The first statement tells you 16 students study both French and Japanese. That means 0.04x is equal to 16. What will be the value of x? What will be the value of x without 400? I asked you this question because you should have said we don't need that answer. Okay, we don't need that answer. Do we need the answer? Please tell me. Is y fixed or not fixed here? Y. Y is how much? That value is y. Let's call it y here. Okay, I didn't name it. Let's call this value as y, whatever it is. Is y fixed or not fixed? So it doesn't matter what the value of x is. It just doesn't matter. So the first statement is definitely not sufficient. But yeah, if you calculate, x will come out 400. This is not enough. Now do not carry forward information from the first to the second statement at all. 10% of the students who study Japanese also study French. That means out of y, 10% also are in this group. So this should be equal to how much? 0.1 y. But I am not using the first statement. So now I get 0.04x is equal to 0.1 y. What will be x divided by y here? 0.1 by 0.04, like 10 by 4, 5 by 2. If x by y is 5 by 2, x has to be greater than y. So B is your answer. I'll give you a minute. Please see what we have done. Yeah, I'll do that. Yeah, so let's call it y. Yeah, so I'll know, but I don't know 0.1 y from here. I'll know 0.04x is 16, so I'll get the value of x. Yeah, it's 16. 0.04x is 16. Is that clear or not? So, yeah. So can I say 0.04x is 16 from the first? That will give me x as 400. But I don't know anything about y. Y could be 500 also, 300 also. So not sufficient. Yes, absolutely. You don't combine if either statement is enough. Only when there are two variables in which an overlap is possible. That's it. Overlapping sets. Any doubt? Please tell me. Please ask me whatever has been a concern so far. Yes, second part. 10% students who study Japanese also study French. What does that tell you? What is the number of students studying Japanese? Why? I don't know that value. That could be 105, that could be 1000 also. So 10% of those people also study French. So where is the combination of French and Japanese? This is the overlapping of French and Japanese. So that value should be 10% of y, that is 0.1 y. Just equate the two and you will get x is greater than y. We have done the first 10 questions. I would want you to take a couple of minutes and revise the first 10 before I move on, because I'm sure there will always be some rough edges still. So just do that bit and then let's solve the remaining questions. Absolutely. Yes. Because that will be 50 or some value. So yeah, totally correct. Very nice. Good observation. Yeah, absolutely. No, no, both gives. If both give no, then why will you combine? Why will you combine? Take some time. Please revise what we have done in the first 10. If you have a problem anywhere, just ask. Yes. 1 second. Come. But is that clear or not? No, 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 no. Why you subtract? So, okay, okay, fine. You may subtract also. So, x minus 1 into y plus z is equal. Take x minus 1. Take x minus 1 common from here. Is it okay? This is nothing but minus of x minus 1. So, this will become minus z basically. Y minus z. X minus 1 multiplied by y minus z is equal. For two numbers to be even, product, this could be even also, this could be odd and even also. So x minus 1 is even also, odd also. So x could be even, odd both. Yeah. Yeah, x will surely be less than y because y is 100. Yeah, so they won't give a situation like this. But what he asked me as an independent statement, would that have been correct? Yes, it would have been correct. Mod of x is greater than 1, that much is clear. Okay, so if I say minus 2, what is the mod of minus 2? Plus 2 or minus 2? So mod of minus 2 is also 2 and mod of 2 is also 2. That means a minus b can be equal to 2 also, a minus b can be equal to minus 2 also. So I am not sure because x, what is the question? Is x positive? Did you write mod of x greater than 1? Yeah, but okay, let's say x is 2 and x is minus 2. In both the cases this will be satisfied. The question is only, is x negative? So yeah, 1 second. Yeah. You don't need to because that won't really compare with y, but it's perfectly fine. Okay, you should do that, but normally the two statements don't contradict, so it's perfectly fine. You should do that anyway, it's okay, perfectly fine. Because that is the guess I would have taken. 4% of something is 16, so obviously 100% is 400 very quickly. Yes. Uh, if you put 100 rupees for 2 years, how much will they become? Yeah, so if I put 1000, so this is 1000. If I put 100, what will it become? Okay, if you put 1000, what will it become? How much percent is 1.15 extra? 15%. That's it. So in 2 years, I am getting more than 15% interest. That much I can understand. Right? 15% extra. Yes. We didn't cancel out these options, but because both numbers are greater than 2 and one of the numbers is 1 and 2 here, can't work. Right? Both numbers are greater than 2. Is this clear or no? So that because I'll get an answer, right? If you calculate, I'll get the answer as 10%. So there is a formula given, everything else is given. So you calculate, you'll get the value of r. You'll get that. It's written one of them is not a factor of the other. If I take 8 by 4, then 4 is a factor of 8. Yes. Yeah, this is clear. A minus b is less than 0. What does that mean? X is negative. A minus b, what will this become? Less than 0. That means x is less than 0. That is x is negative. That's it. Yeah. But that's the point. Mod of a minus b, let's say mod of x. A minus b could be 2 and a minus b minus 2 also. Mod of minus 2 will also become 2. So a minus b could be positive and negative both. One is, yeah, it could be anything except between minus 1 and 1. Yeah. Yeah.
So
10% of the Japanese, not 10% of the student. Read the question. 10% of the students who study Japanese is not 10% of the overall number of students. Right? Clear? Alright. No, no, figure doesn't say anything ever. That's why they say not drawn to scale. Even if it looks acute, it could be obtuse. Unless they mention something. Shall I move on to the next 10 then? Fine. Okay, tell me what are your observations. If you have to get them right the next time, tell me 4-5 things that you need to do correctly that you missed out this time. So we are on the same page after that and we move on. Tell me, what do you have to take care of that you didn't this? Sorry? Don't combine both the options straight away. Yeah, carry forward. Say, solve the main question, simplify it. Yes, and don't assume. Assumptions essentially. Okay, values. Yes. The both the statements. Okay, so they do not contradict. All right. And I can tell you one. Yes. Yeah, absolutely. Either statement is sufficient. We don't need to combine. Not both. Either. Yeah. Don't fall for figures. Okay. I don't comment on that. Let's see. 11. Now here you are asked exactly what the value of x is. So I have to actually get that value. So you're given x cube is a 2-digit positive odd integer. So x cube could be equal to 11 or first statement definitely not sufficient. Similarly, second statement x to 4 is a positive odd integer. X to the power 4 could have been again not sufficient. And maybe you've seen this question before in have you seen this one? Sorry. Was it there in those 10 questions in the beginning video? I'm sure this something similar was there. So this is not sufficient. If you combine, you have to make sure one thing, x to the power 3 or x cube is an integer and x to the power 4 is also an integer. What does that tell you about x? X has to be irrational or rational only. Okay. x to the power 4 is x cube into x. Now this has to be, this is an integer and this is also an integer. So x will be an integer divided by another integer. So rational or irrational? Alright. If x is a rational number, can x cube be taken as 11 or 13 or 15 or something, or no way? So what is the only value of x now in the entire 2-digit spectrum? X cube can only be 27 and x could only be 3 if you want this for sure. Otherwise x will be cube root of 11, cube root of 17, which is all going to be irrational. Which is the only number whose cube root in odd numbers in 2 digits, whose cube root is going to be an integer or a rational number? 27. Only 27 cube root is going to give me an integer value. No other number in the first up to 99, no other number in 2-digit odd numbers. So the value of x has to be only equal to 3 and no other value. And that is why, what is the answer now? C. Yeah. So you are given x cube is an integer, x to the power 4 is an integer. So if I want x, I have to divide x to the power 4 divided by x cube. So integer divided by integer is never going to be an irrational number. Irrational is clear or not? Irrational number is whose square root will not come out the way normal square roots come out. So something like cube root of 17 is an irrational number. Something like that. Okay, question number 12. Is x negative, x square is positive and x cube is not positive? Remember, let's see. X square is positive, so x square is, let's say 36, x could be 6 or, so this is definitely not sufficient. X cube is non-positive, so x cube could be either 0 or negative. So x could be 0 or, is x only negative? Again not sufficient. If you combine, what is the value of x, negative or positive only, or 0 also? If you combine, if you take 0, x square can't be positive. So what is the only value of x? Negative? X is surely negative. Okay. So again, C is my answer. Clear? Thirteenth problem, let's see. Just for simplicity, assume n by 18 is an integer. So n by 18 is x, sorry. So your question is x an integer? This says 5x is an integer. This says 3x is an integer. Always remember, you can simplify the question. Otherwise, it would be quite a lot of work for you. If 5x is an integer, what is your guess? X has to be integer or not necessary? Not necessary. I can say 5x equal to 1. So x is 1 by 5, which is not an integer. But 5x equal to 5, x is 1, which is an integer. So this is not sufficient. Similarly, I can say 3x equal to 1, x is 1 by 3, which is not sufficient. 3x equal to 3, x is 1, which is, sorry, not an integer. This is an integer. So again, this is not sufficient. if I combine and say 5x is an integer, 3x is an integer. So if you subtract, then 2x would be an integer, and subtract again, then there is no point. X has to be there in the question. You shouldn't do that step. No, it's not that we need to subtract. There is nothing mathematically wrong with it. I need to get to x. If 3x is an integer and 2x is an integer, then x has to be, right? Yes, 1 sec. 0. No, 0 is neither positive nor negative. 0 is always even, but not positive. Yes, you had a question. Who had a question? Yes. Someone had a question? Yeah, sorry. Yeah. You meant work it out that way. This is exactly what I've done. Why don't you take 5n by 18 as 1? You are taking n as an integer to start with. Yeah, it could be 1 or not. No. Can 5n by 18 be equal to 1? So n by 18 will be 1 by 5, which is not an integer. Got the idea? If 5n by 18 equal to 1, am I wrong? Then n by 18 will be 1 by 5, which is not an integer. I'm sure you were assuming n to be an integer to start with. That is why all this happened. You can't assume that. Yes, please. What was there? Let me just check first. Question number 12. Yeah, not positive means 0 or negative. That is why. So x can't be 0. 0 square is 0. How is it positive? I'm not assuming, it's given. It's given. There is no assumption here. Okay, tell me what you're asking. Still ask. Or 0. Yes. 0 square is 0. No, that is not what you. I have to combine it with the first statement. I am just saying x is either 0 or negative. First, full stop. We shouldn't. If x cube is 0 or negative, x is either 0 or negative. If I combine it with this one, x can't be 0, so x can only be negative. That's it. It's the easiest question you can get. What are we talking about? Let's see. Okay, one more time. What does this mean to you? X cube could be either 0 or, which means x could be 0 or negative. Combine it with this one, x can't be 0. So x has to be negative. Okay, 14th problem. What does it ask you? Let's see. Could you just, okay, let me just see it. Sum of consecutive positive integers is 45. What is the value of n? So n is even and n is less than 9. Consecutive n okay. What answer did you get for this problem? What was the answer? A. E. How many numbers according to you can sum up to 45? How many consecutive numbers? 1 to 9 is 45? But n is even. The number of terms should be even. Is that the only combination? 10, 11, 12 I can't take. This should be even numbers. 14, 15. I'd want even number of numbers, please. Not odd number. Odd number of numbers will be too many of them. Yes. I should have either 2 numbers or 4 numbers or 6 numbers or 8 numbers summing up to 45. 0 to 9. But is it given positive integers or not? 0 is not allowed, please. So is that the only combination? 22 and 23 taken. Is that the only combination? 5, 6, 7, 8, 9, 10 is also there. Okay, so let's see how to approach a problem like that. So n could be either 2 or n could be 4 or n could be 6, etc. We don't know how many, so let's say if n is 2, how should I assume 2 consecutive integers? X and if x plus 1 is 45, I should only check whether I'll get an integer value for x or a fraction value for x. Okay, so x plus 1 is 45. Can x be an integer or fraction? 2x plus 1 is 45. So 2x is 44. So x is 22. So the two numbers are 22 and if x is not an integer, then that's an invalid series. Let's take how to assume 4 consecutive numbers. So x2, x plus 3. 1 plus 2 plus 3 is 6. 45 minus 6 is 39. 39 divided by 4 is not an integer. This is not going to work because x will come out a fraction. If n is 6, x to x plus 5. What is the sum of 1 to 5? 15. 6x is, so 45 minus 15 is 30. 6x equal to 30, x is 5. So x is equal to 5 means 5 to 10. How many terms? So n could be equal to 2 and n could be equal to 6 and the answer is E. There is no need to check further. Yeah. Which formula? No, that formula is only when you start from 1. It's not for any consecutive number. If you start from 1, then that formula is correct. But if you start from 9, then that formula is not correct. No, you can't get it. You can't get 5. You can't get, if 5x is 8, 3x can never be 3. How are you assuming the two things together? No, it won't come. It won't. It can't happen. Then 5x and 3x both can't be integers. You try it. Is this clear? The approach? What's the next question? Let's see. 15th. First, x square is positive. X mod y is not positive. Okay, let's see. If x square is positive, x could be positive and negative. So not sufficient. This one. X into mod y is not positive. Now I'm sure you realize what mistake you made already, may have made. Not positive can mean 0 or negative. So x, y and x mod y. I'll assume all the possible values in this case. X is positive, y is 0, x is negative, y is 0, x is negative, y is negative, x is negative, y is positive. 0, 0, negative, negative. So just try, you will do it on your own, just try. Will the answer be E or not? Check. Which one? No, because x square is positive. So I'm not, that will be too much work. You can do that, why not? X is 0, y is 0, x is 0, y is positive, x is 0, y is negative. But when you combine it, it will disappear. You can do that. Okay, are these totally in sync with both the statements? Please tell me. Is the first statement satisfying this? X square is positive. Is the second statement satisfying x into mod y is not positive? So can I say even on combining this table will finally remain? Even on combining, can this table remain? Okay. What would have been the other possibilities? Let's write all the possibilities. Forget the first statement. From the second statement it could be 0 also. So x could have been 0, y could have been 0, x could have been negative and y could have been 0. Sorry, that's already done. Is this clear? But I don't need to take those values, that's alright, because this is just increasing your work otherwise. How should you start? One more time. If x into mod y is not positive, take 0 or negative. How can this product be 0? Think about it. How can this product be 0? When both are 0? Or one is positive, the other is 0. One is negative, the other is 0. All of them I have considered. So this remains, this is valid. Now if I want the other thing to be negative, mod y will anyway become positive. So you can take everything for y plus or minus, but for x what should you take only? Negative. So this entire table, even if I combine it with the first one, I'll still not be sure x is negative. I have both values possible. So the only mistake you may make is in interpretation of non-positive and non-negative. Any other question on this so far, whatever we've done? Yes, please. It's given. Not positive is 0 or negative. Yeah. Okay, let's see 16th. If you have done the video, this question would be a repeat, I think. Was it there? Have you seen this problem in the video? If you have done the video, I have asked you to watch the demo video for sure, compulsory. So if I take what is x, I need an exact value. In this case, I can take x equal to 0, 1, minus 1, whatever. So this is not sufficient. In this case, we know that mod of x has to be greater than or equal to 0, which implies 3x minus 2 has to be greater than or equal to 0, which implies x has to be greater than or equal to 2 by 3. This is our condition. Before we start, this condition has to be satisfied. Now, whenever you are given mod x, you can write x or minus x. So, x is equal to 3x minus 2. It will give me x equal to 1, which is okay. Minus x is equal to 3x minus 2, which will give me x equal to 1 by 2, which is alright, but it does not satisfy the basic assumption. What is the assumption? X has to be greater or equal to 2 by 3. So this value, although is a solution, is not correct. So from the second statement, x equal to 1 only, okay, and B is my answer. Some surprise. What's the surprise? Okay, I'll suggest one. Substitute x equal to 1 by 2 again, please. Substitute x equal to 1 by 2. Does it satisfy or not satisfy accordingly? The root of an equation must satisfy it. But x is equal to half does not satisfy the original equation. In any mod equation, this must be a thumb rule for you. You must check it again. Sometimes the original equation will not be satisfied. So that is called an invalid root. Although the answer will come, but it will not satisfy the original equation. Yes. Is the solving clear? This one is clear first. Second, whenever you see mod of x, the condition is that the value of that 3x minus 2 has to be either greater than 0 or equal to 0. So that is the condition. 3x minus 2 should be greater than or equal to 0. So the condition is x should be greater than or equal to 2 by 3. When I substitute x as x and minus x, mod of x as x and minus x, I get two values. One of them is in sync with that condition, the other is not in sync with that condition. There is another way to look at this problem if you want to be doubly sure of what we are doing. When you assume, let's see, this also is very crucial for you. When you assume let mod of x be equal to x, what is your assumption? X is, and when you assume let mod of x be equal to minus x, what is your assumption? X is negative. Now you start with an assumption x is negative and you get the answer as x equal to 1 by 2. So this answer is anyway invalid. So in all the three cases, it is an invalid answer. So the value of x is only 1. Now this is one question in which if you have seen it for the first time, or even if you saw it a month ago and still, you may commit a mistake 10 times, the same mistake. And I can guarantee the same mistake might have happened also for some of you. Did it happen? You may have seen it and forgotten it maybe. Or first time could you have got it right by any chance? First time, what would have been the two answers for sure for you? Both 1 and 1 by 2. So just be aware, any mod equation always substitute back. That's the best way. Always. Let's see 17. Into mod of x square minus 4 is equal to y minus 2, the first statement. Second is y is what value. The only condition that you need to know about mods is that they are positive. So the first statement, can I say this means y minus 2 should be greater than or equal to 0? So guaranteed y is greater than or equal to 2. If y is less than 2, then this will become negative. Mod cannot be negative. So this is the, but this is not sufficient. Second statement, you may solve it in two ways. 3 minus y is equal to 11 and 3 minus y equal to minus 11. So you will get y is equal to minus 8 and y equal to 14. Again not sufficient. Combine, y must be greater than or equal to 2. That means y is equal to, so C is your answer. See. What do you think you would have marked here? E. Right? You thought first statement is of no use actually. Want to change the temperature or something? You can do that if you want for these two ACs. If you want, I think I can sense it. So you can change the temperature if you want, please. Alright, let's see. 18th problem. Without even picking up the pen, what is your answer? Without even picking up the pen. Can I say directly enough to buy doesn't give me an exact value? I may have enough money to buy something does not mean I have the exact money to buy it. So this is a question that is given as a bonus. The answer is straight away E, nothing required, no calculation. Enough does not mean the same value. So if I say $10 is enough to buy 5 notepads and 3 markers, the value of 5 notepads and 3 markers may be $1, maybe half a dollar, maybe $5. So there is no way you can get the answer. Qualitative question, not quantitative in a way. Let's see the 19th problem. Enough to buy, if you say I have enough money to buy a house, does not mean I have the exact money to buy that house. Logically, that's the way. So then 1 kilogram of certain coffee, so x plus y should be equal to 1 kg or 1. This is your first thing given to you. So y equal to 1 minus x or x is equal to 1 minus y. All this you can derive. C equal to 6.5x plus 8.5y. Is x precisely less than 0.8? So the first statement is y is greater than 0.15. Second statement. Let's see how to approach a problem like this. Suppose y is equal to 0.16, then x would be 0.84. So use this. X plus y is 1. So your question is x less than 0.8? I would have gotten no answer. But if y is equal to 0.25, then x would have been then I would have got a yes answer. So the first statement is not sufficient. Now you are asked the value of x, so you have to eliminate y. So in place of y you will write 1 minus x. So my value will become 6.5x plus 8.5 into 1 minus x greater than or equal to 7.3. Please solve this and tell me what this comes to quickly. X is less than or greater than? X is less than or equal to 0.6. Now ask this question, is x less than 0.8? What is your answer? So it's very easy to solve this. 6.5x and minus 8.5x will become minus 2x, and this will become greater than or equal to minus. So when you remove the negative sign from both sides, what happens? Sign changes. Okay, 20th problem. What is the answer? Straightforward. Was this part of your video? Maybe, I am not sure. Was it there? It's already there. Okay, one important thing here. If there are two simultaneous equations given to you, usually will you need both or only one? What is given in the theory on first page? If two simultaneous equations are available in DS, usually how many are required? One. One is enough. So very rarely will you get the answer as C here. Very rarely. So if I say total of 6 pencils, so x plus y is 6. First statement. Second statement says 23x plus 21y is equal to 130. Now if you are in a hurry, you would say, okay, two equations, two unknowns, I can solve this. So the answer is C. Wrong approach. Bad approach. C trap. This is a certified C trap answer. So in terms of integers, if there is only one pair of integers, then that is all that I was looking for. How quickly to get this answer? Let's see. So if I have to look at 130, 21 into 6 is 130, around 130, and 23 into 5, 6 is around 130. So what is the maximum value of x or y that can be? 6. It can't be more than 6. So if it is 6, let's say it could be 0 and 6, but 0 and 6 won't satisfy. 21 into 6 never reaches that. It could be 1 and 5. So 1 and 5 will be how much? 5. This will be 105. This will be 23. It won't reach 130. And so on. Now if you finally do this, you will get the answer very quickly. It could be 2 and 4. So 23 into 2, 46. 84. 86 plus 84 plus 46. 130. So 2 and 4. All you have to make sure is there is no other pair. There should be no other pair. That's it. So you will find only one pair will finally satisfy this, and the answer will be B. In such a question, don't really ever mark C unless you verify. I haven't seen any problem in which the trap is not there. So it's a C trap problem. (21) is the measure of one of the interior angles equal to 60 degrees, and then you are given two of the angles are right angles, and one of them is twice the other. So first of all, 90, 90. I can take x and 2x. This is one possibility. I can take 90, 90, and this itself could be 2x. And then this could be x, and this could be some other number. Possible or not? Now let's see what will be the value here. This will be 60 and 120, and this will be 45 and 135. So is one of the angles surely equal to 60 degree? What is your answer? Is one angle surely equal to 60 degree? Not necessary or necessary? Not necessary. So E is your answer. They do not say that of the remaining two angles, one is double the other. 90 itself could be double some angle. No, it's not second. I'm just combining because you know that each statement alone will not suffice. If I say 90 is double of 45, is that logical or not? From both the statements combined. So then, what is your question? Is one angle surely equal to 60 degree? I'm not sure, but can this lead to C as an answer by any chance? Did you feel C as the answer, that if you combine 19, 90, 60, 120 should be my final four values? So this is again a trap question in a way. It's only the language. See, again and again I am telling you, there are only two things. You just think about the language and the basic traps. Just take care of these two things. It's not difficult by any chance. 22nd problem. B 0 and 5 root 3. see 6 and 3 root 3, and it's an equilateral triangle, right? Yeah. Straightforward B, right? I don't, sorry. Okay, so in an equilateral triangle, what all do we know? Let's see quickly. What is the height of the triangle? What is the value? H is always equal to, and the area is root 3 by 4 a square. So you know one thing for sure, B is from the origin, so that will not make any sense. I don't know what the actual side is. So the first statement is of no use. Don't combine anything, please. Second statement, if I take the x coordinate here, this will give me the height of the triangle, 6. If the height of the triangle is 6, I can say root 3 by 2 a equal to 6. I'll get a equal to 12 by root 3, and I can get the area of the triangle by this formula, which I don't need to calculate. So what is the answer? B. I'm hoping this would have been correct for all of you. This is not a difficult one. Even if you don't remember the exact formula, you should know that in a symmetrical figure, if you know one value, you know all the values for some reason. Okay, let's see. What is the sum of digits of n? And you're given y to the power 4 is a 2-digit positive odd number, and n is divisible by y square. Now this is a question, once again you will feel y equal to 3 only. Is it necessary? It's not given to be an integer, so don't make that mistake. So what all can be the value of y square or y to the power 4? Can I say y to the power 4 can be easily taken as 25 or 49 or 81? Are we comfortable with these three numbers? So y square can be equal to 5 or 7 or 9 among many other values. So n is divisible by 5 or 7 or 9. Is it possible for me to tell exactly what the sum of digits of n will be? Always. Is it possible? Because n could be 25, n could be 35, n could be 49, n could be 81. I don't know what to do. So I can't get a fixed answer. Just imagine if I just change this question to y is an integer, then what is the answer? Y is an integer. Then y should be only equal to 3. Then n is divisible by 9. And all the 2-digit numbers that are divisible by 9 have the same sum, 9. So even if you say, okay, I had 18 and 27 and 36 and 45, all of them will have the same sum of 9, then the answer would have been C. In this case, the answer is E. Just add one line and say y is an integer, the answer is C. Any doubt here? this question is part of your discussion already. So 24th I am still taking it just to explain. Again, a C trap, please you should avoid this. So x and y, so they are asking what is the value of x. First one, x is equal to y, obviously not sufficient. Second, 15x plus 29y equal to 440. Don't do the same mistake of taking them as two equations, two unknowns. Can you get a unique solution to the second equation? You would have watched it. If you watched it, you know the answer anyway. But if you not, or if you forgot, let's see. So the biggest clue here is 15 plus 29 is 44. This if you can identify, then you know very clearly x equal to 10 and y equal to 10 will surely satisfy. Also this is ending in 0 and this is going to end in only 0 or 5. 15 into something will end in 0 or 5. That means 29 into something should also end in either 5 or 0. Then you can take what all values of 29 into what will end in 5 or 0. So what are the values? I can't take y equal to 1. I can't take y equal to 2, 3. So what is the only value I can take? 5. So if I take y equal to 5, I get 29 into 5 is 145. 440 minus 145, 295. 295 divided by 15, not an integer. So y equal to 5 is ruled out. Y equal to 10 has already been taken, so don't waste time. Y equal to 15 after this. 29 into 15, so 30 into 15 is 450, 29 into 15 will be 435. 440 minus 435, 5 divided by 15, not an integer. So there is no other solution except 10 and 10. So B is my answer. Classic C trap problem. Some of the questions are repeated from that video because I want you to understand this kind of, these questions are so common. Okay, by mistake, suppose you go wrong on this problem on your actual exam. Will you ever know that you've made a mistake? What would be your feeling? I got everything right on my test. Why did I end up with a 48 on quant? I mean, this is what people ask me again and again when they get a bad score. That not a single question was difficult. I think I got everything right, and 48 means you got 13, 14 wrong answers essentially. Now 13, 14 wrong is unbelievable when you just feel everything was easy, and this is one example. You go wrong in any problem and still people score well, that means it's easy to finally get past this issue of silly mistakes. 25. We have done this problem in the video. Still, let's see x factorial plus if x is a positive integer. Now this is one very frustrating problem if you do it by the conventional approach and keep getting an answer. So let's see, if you're given x is less than 0 and x is even, you try x equal to 1, let's say. So 1 factorial plus 1 will be 3, which is prime. So yes, x equal to 2, let's say. 2 factorial plus 2 plus 1 is 5, 5 is prime. X equal to 3, 3 factorial 6 plus 3 plus 1, 10, which is not prime. So you stop there, not sufficient. X is even, so x is 2, 4, 6, 8. This becomes classic because 2 plus 1 is 5, which is prime. 4 factorial plus 4 plus 1 is 24 plus 5, which is 29, which is prime. If you have this 6 factorial plus 6 plus 1, which will come to 627, although very difficult to calculate. And again this is prime. And I'm very sure nobody would want to try the next value. Would you have tried the next value on your own if you were solving? 8 factorial plus 8 plus 1. Because 8 factorial actually will come out to 40,320, and then you do that, and then also you don't know whether it's prime or not prime. So if you solve this will come out non-prime. but yes, we know what I'm talking about. So in a problem like this, the GMAT has given you a lot of clues. First thing, the two statements never contradict each other. If you look at these two statements together, what are the boundary values of x? 2 and 8. So you should try 2 and 8 only and see whether there is a contradiction or not. If I try x equal to 2 and x equal to 8, I'll get, in this case I'll get 2 factorial plus 2 plus 1, which is 5 prime, 8 factorial plus 8 plus 1, which is going to be 8 factorial plus 9. I can write this as 3x plus 3y and take 3 common and x plus y, which is a multiple of 3, which is not going to be prime. So not sufficient, and E is my answer. How can I write it 3x plus 3y? Let's see. 8 factorial will contain 1, 2 into, so 3 is part of 8 factorial. So I can write 3 into an integer. And 9 is anyway 3 multiplied by 3. So I can write this as 3x plus 3y or something. Multiple of 3, which is not going to be a prime number. Boundary values from by looking at both the statements together. X is less than 10 and x is even. What are the boundary values? Highest value and lowest value. It does not mean I combined, okay? It does not mean I combined. From the first statement, are these two valid values? From the second statement also, these two are valid values. Take a minute or two if you want. You can scan all the remaining problems after 10th and tell me if you have still got some doubts or something. Let me know. Yeah. Yeah. 1 second. Let me write it. Read this, please. Just read this. No, I don't have to do, because if 3x is an integer already known to me, 2x is also an integer, then why do I need to do this? Then x has to be, if 3x is an integer, 2x is an integer, for sure x has to be a subtraction of the two, integer minus 2x. What's your doubt here? Okay, one second. Yeah, I'll explain. Yes, I'll explain. So there is one question a lot of you are asking, so let me explain it again. 23rd. N is divisible by square of y. This is one. And second, y to the power 4 is a 2-digit positive odd integer. If I take y to the power 4 as 25, am I making a mistake or not making a mistake? Please. Not making a mistake, is it clear? So what will n be divisible by? N is, so what will be y square? Y square will be 5. So n is divisible by 5. If n is divisible by 5, what all values can I take? 25, 30, 35. The sum of digits is 7 here, 3 here and 8 here. You are asked what is the sum of digits? I am not sure exactly what the value is. Now this is what I explained. You tell me where the doubt was. I have randomly taken a value of n to the y to the power 4 as 25 and I have seen y square is 5 and n is divisible by 5. Is this logically making sense? You can take anything you want so long as you are satisfying them. Did it make sense now? Okay. Which was the other question you asked me? 21. Who had a doubt with that? 21. Yeah. There are 4 angles given to you. This is 90, this is 90. These 2 angles I don't know anything about. You are just given that out of these 4 angles, one of them is twice the other. Now this is totally up to me. I can take this as 2x and this as x. And when I put the sum of 4 angles as 360, I'll get x is equal to 60 and y equal to 120. And it is totally up to me to say 90, x and 2x this one. And then some other value. And the sum as 360. If I do this, in that case, x will become 45. So 90, 90, 45. So this has to be 135. You tell me where the doubt is. Is it clear? Alright. Any other thing? 8 factorial means what to you? What does it mean? 1, 2, 3 up to 8 multiplied. So 3 is part of it or not? So 3 into something. So 3 multiplied by some number. And 9 is anyway 3 multiplied by some other number. So it's going to be a multiple of 3 after. Right? Any other doubt in this? Any other doubt? So what you need to do in data sufficiency right now is this. This is the approach that you need to take. I just wanted to give you an introduction so that now when we explain it, let's say when I have only a geometry class or only a only an inequalities or numbers class, I don't have to explain the concept of DS again and again to you. A lot of questions that we'll solve will be DS oriented because DS is usually asked in more numbers. If you do well, very few problem solving questions are asked. If you are doing badly, then a lot of problem solving is asked. So this is how the GMAT works essentially. For the session that I have tomorrow for sentence correction, that book that I sent you, Maximize Your Writing Score, it is not really the GMAT level grammar that you need to read, but primer to that. Something that you have to know. So if you have forgotten that out of the 2 words, which one is an adjective, which one is a verb and so on, you should read that fully. It has very basic chapters of, it may take you time, but it is not a tough book to finish, I think. How much have we done with it already? Have we finished some part? Easy but, right? You should still do that bit. And the 15 questions I gave you the last time, that plus maybe some basics of sentence correction I'll discuss. So how to approach it? I would suggest not reading the solutions to the 15 questions because they were part of the handout. So if you have not read, don't read the solutions. Your understanding will be very, very different if you have read the solution. If you have already read it, it's alright. But if you have not read the solutions, don't read them till tomorrow. Okay. So we'll have the session on SC plus some idea about the next 2 sessions, what we are going to be doing. I'll talk about tomorrow. Okay. See you then. Thank you. The session.